Now we will see the source transformation. In that we have to convert the voltage source into the current source, or the series combination of voltage source and the resistor into the parallel combination of current source and the resistance. Always remember that resistor is always in series with the voltage source and the current is always in parallel with the resistance. That means we have to convert this voltage source into current source by simply using a Ohm's law. So simply V is equal to IR, or simply I is equal to V upon R. So we have to convert the voltage source into the current source. So simply we are converting by using this formula. Or see here, we know the voltage and the resistance, so simply this current will be I is equal to V upon R. If the voltage is 20 and the current is 4 ohm, then the voltage is 20 and the 20 volt and the resistance is 4 ohm, then the current will be 20 upon 4 as 5 ampere. That is 5 ampere. And we are not changing this resistance, we are putting resistor as it is. And if we have to convert this current source or the parallel combination of current source and the resistance into the series combination of voltage and the resistance, we are simply using this formula. So simply V is equal to I into R. Here we know the current, suppose it is 5 ampere and the resistance is 4. So we are simply multiplying the current and the resistance and getting the voltage. So simply it is 5 into 4, it is 5 4s are 20, so it is 20 volt, and connecting the resistance which is in series with the voltage source, and we are not changing this resistor, we are putting resistor as it is 4 ohm. In that we have to consider the different conditions like this. Suppose in the question, if the voltage source having the parallel resistance, this is the parallel resistance to the voltage source, then this resistor we are considering it as redundant. It is redundant and there is no any use in the circuit, because the resistor is always in series with the voltage source. And if there is a resistance which is connected in series with the current source, then this current will again be redundant, because the resistor is always in parallel with the current source. So these are the two conditions we have to consider during solving the problems. Then if there are voltage sources in series, we are adding it directly. So simply here we have to see the polarities. Likewise, suppose I am going like this from this terminal to this terminal, so simply the circuit will be like this. See here, the final voltage which I have find it out, which is V, is equal to, see here, the current direction which I have considered it is -2 plus, so simply it is plus V1. Then here it is going from plus to minus, so simply it is -2, and then it is -2 plus for the V3, so it is plus V3. Or simply the voltages which is having the same polarities, we are directly adding it and subtracting the other one which is having the different polarities. So simply it is V1 plus V3 minus V2, and here we are giving the polarities at the final voltage will be, suppose the voltage V3 is 5 volt, voltage V1 is 2 volt, and the voltage V2 is 1 volt. That means the same polarity is having V3 and the V1, and it is the total addition is 5 plus 2 is 7 volt minus V2 is 1 volt, because here 1 volt is the lesser one, therefore we are giving the polarities of the higher voltage like this. But if the V2 is having 9 volt, if the V2 is 9 volt, then see here the voltages which is having the same polarities V3 and V1 will be added, which is equal to 5 plus 7 is 5 plus 2 is 7 volt, but V2 which is equal to 9 volt, which is greater than, so simply V2 is greater than V1 plus V3, then the final voltage having the polarities of V2, because the V2 is having the higher voltage, so the polarities of the voltage will be changed like this, minus and plus, as that of the V2. Like this we have to give the polarities for the voltages. Then in the current source, when the current sources are parallel or in parallel, we are adding it. When there is in series, we are not adding it. Similarly, voltage sources in series, we are adding it, but the current sources in parallel, we are adding it. So same case, the current sources which is having the same direction, we will get add, and subtracted the other one which is having the different direction. So simply here, suppose I1 and the I3 is having the same direction, so simply it is 3 ampere plus 4 ampere which is equal to 7 ampere minus 2 ampere, and the direction which we are giving it is higher current of higher current. Suppose this is the final current like this, and I am giving the direction of the higher voltages, so simply which is equal to I1 plus I3 minus I2. Then see here we have considered the I1 is 3 ampere, I3 is the 4 ampere, having the same direction I1 and I3, we are adding it and subtracting the I2 current, and giving the direction of the higher current which is having the 7 ampere. Then if this I2 current is having 9 ampere current, then the direction of the current will be changed, because the I1 and the addition of the I1 and I3 is 7 ampere, and but I2 is the 9 ampere which is greater than the 7 ampere. Therefore we have to change the direction of current like this, which is that of 9 ampere current, which is that of I2 current. So these are the conditions we have to consider during solving the problems. Thank you. Now the first problem, which is based on the source transformation. Replace the given network with a single current source and a resistor. We have to replace this network with a single current source and the resistance. Firstly, see in the circuit, here the voltage source 20 source having the parallel resistance 5 ohm. This is the parallel resistance in the voltage source. So simply we are calling the 5 ohm resistor is redundant. It is redundant, and we are not considering in the circuit. So first we are replacing this the parallel combination of the current and the resistance into the series combination of the voltage and resistance. So simply for first network, we are replacing this parallel combination of current and the resistance into the series combination of voltage and the resistance. Simply I is equal to 10 ampere and resistance is equal to 6 ohm. So by Ohm's law, V is equal to IR, or which is equal to I is 10 and the resistance is 6, which is equal to 60 volt. So voltage is 60 volt, that means V is equal to 60 volt and resistance is equal to 6 ohm. We are not changing it, resistance as it is, we are putting resistance as it is. That means the final network will be like this. We are replacing this network into the voltage source which is in series with the resistance. So simply this is the series resistance of 6 ohm with the voltage source 60 volt. It means this 60 volt voltage source will be connected to this 20 volt source. That means like this, it is circuit will be like this. It is 20 volt. This is the A terminal and this terminal is B. Now the voltage source 60 and the 20 is in series, therefore we will get added directly because both are having the same polarities. Here the polarity to these voltage source we are giving like this. Suppose this is in the upward direction, current source in the upward direction, then with the conversion in the voltage source we are replacing the arrow with the positive and the below side we are replacing it with negative. So simply current source having this direction which is upward direction, therefore we have considered the plus and the minus. So simply both having the 60 volt and the 20 volt same polarities. So simply it is 60 plus 20 will be equal to 80 volt. So circuit will be replaced like this. It is the 6 ohm and the voltage source will be like this. Voltage source is 80 volt. Okay, now the main question, we have to convert it into the current source and the resistance. That means the parallel combination of current source and the resistance. We are converting this network into the current source like this. Simply here V is equal to 80 volt and R is equal to 6 ohm. Therefore I is equal to V upon R, and it is equal to 80 divided by 6. It is equal to simply 13.33 ampere. That means I is equal to 13.33 ampere and the resistance which is equal to 6 ohm. So we are replacing this voltage source which is having the series combination into the parallel combination of current and the resistance, and the direction which we are giving to the current source, the positive terminal which is at the upper side, therefore direction which is to the upper side. So simply the current is 13.33 ampere which is in the parallel resistance 6 ohm. The final answer for this network, you have to replace it into the current source and the resistance. It is 13.33 ampere with the parallel of 6 ohm resistor. Thank you. Now we will see the second problem, which is based on the source transformation. As in that circuit we have to replace the network in the A and the B terminal. Here the current source and the three voltage sources are given in series with the resistance, and the current source is in the parallel with the resistance. We have to replace this network into the one source and the resistance. So simply suppose this is the first network, second, third and the fourth. We are replacing this voltage sources into the current source. So simply for the second network, V is equal to 4 volt and the R is equal to 2 ohm. So simply I is equal to I is equal to V upon R. So simply V is 4 divided by 2, which is equal to 2 ampere, and the direction is upward because positive terminal at the higher level. So simply it is direction will be like this for the current. So we have considered like this. Then for the third network, V is equal to 6 and the R is equal to 3. So simply V is equal to 6 and the R is equal to 3. So I is equal to V upon R. So simply it is 6 upon 3 is equal to 2 ampere. Or the positive terminal at the lower level, or we are considering the current direction like this. Then for fourth network, V is equal to 3 volt and R is equal to 1 ohm. So simply I is equal to V upon R and it is equal to 3 divided by 1, which is equal to 3 ampere, and direction will be like this because positive terminal is at the higher level. So simply direction is like this. Now we are replacing this network with the current source like this. We are not changing this. So the final circuit or final network will be like this. This is 2 ohm which is in the parallel of 1 ampere current source. Now this we are replacing again it with resistance which is in the parallel of current source, and direction of the current is like this. The current is 2 ampere and the resistance which is equal to 2 ohm. We are not changing the resistance, so it is 2 ohm. This is the A terminal. Now for this third network we are replacing like this. Current is equal to 2 ampere and the resistance is 3 ohm. So simply it is the resistance is 3 ohm and the current is 2 ampere, but the direction is downward. Then for this network the resistance is 1 ohm, it is not get changed, and the current is 3 ampere. So simply like this, current is 3 ampere. Always remember that we are converting the series combination of voltage and resistance into the parallel combination of current and the resistance, or parallel combination of current and resistance into the series combination of voltage and the resistance. As we have seen in the condition, fourth condition in the first lecture, like this, when the two current sources are in parallel, we are directly adding it. So simply here 1 ampere and the 2 ampere is in the parallel and it is having the same direction. So simply it is 3 ampere and I am replacing it with one current source like this. This is the one current source, and here the 2 ohm and the 2 ohm are in the parallel. So simply the parallel combination of 2 ohm is 2 parallel with 2, which is equal to 1 ohm. This is the A terminal. Then here again this 2 ampere current source and the 3 ampere current source are in the parallel, or here the directions are opposite. So we are subtracting the currents. Higher current is 3 ampere, so this is 3 minus 2 is 1 ampere, and we are giving the direction of the higher current. So simply it is in the upward direction like this, and the resistance will be parallel combination of 3 ohm and the 1 ohm, which is equal to 0.75 ohm. This is B terminal. How we are finding the parallel combination? It is simply 3 into 1 divided by 3 plus 1, which is equal to 3 divided by 4, which is equal to 0.75 ohm. This is the parallel combination. Similarly here, then see here, we are replacing this parallel combination of resistance and the current into the voltage sources. So this current is addition of the two currents is 2 ampere and the 1 ampere it is 3 ampere, and here it is the subtraction, so 3 minus 2 it is 1 ampere. Now we are converting this parallel combination of the current and the resistance into the series combination of voltage and the resistance. So simply, suppose this is first network and the second network. So for first network, I is equal to 3 ampere and R is equal to 1 ohm. So simply V is equal to IR. So it will be 3 into 1, which is equal to 3 volt, and R is equal to 1 ohm. It is not get changed. Then for the second network, I is equal to 1 ampere and R is equal to 0.75 ohm. So therefore V is equal to I into R is equal to 1 into 0.75, which is equal to 0.75 volt, and R is equal to 0.75 ohm. It is not get changed. So now we are replacing this circuit with the voltage source. Okay, like this, we are replacing this network, current and the resistance will be like this. Here the direction of the current is in the upward direction, so higher terminal we are considering it is plus, which is in series with the resistance. Simply it is A terminal. And for the first network, voltage is equal to 3 volt and the resistance is equal to 1 ohm. So voltage is 3 volt and the resistance is 1 ohm. Then for the second network, voltage is 0.75 and the resistance again it is 0.75. So simply, and the direction of the voltage, the polarities for the voltage will be like this: higher is positive and is negative because direction is in upward, or simply it is 0.75 volt and the resistance is again 0.75 volt. This is the B terminal. Now here the 3 volt and the 0.75 volt are in the series. We are directly adding it and having the same polarities. So simply it is 3 plus 0.75, it is 3.75 volt, and again the resistance are in series. We are directly adding it. So simply it is 1 plus 0.5, it is 1.75 ohm. This is the final network between the A and B terminal, which is reducing the one source and the resistance. Thank you.